Welcome to Module 5 of the AI and Machine Learning course. This module covers the basics of neural networks and deep learning, including network architecture, activation functions, and training via forward and backward propagation. It also introduces deep learning models such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs. Learning objectives. By the end of this module, you will be able to 1. Understand the basic architecture and components of neural networks. 2. Describe the process of training neural networks using forward and backward propagation. 3. Identify and apply deep learning models, including CNNs and RNNs. Basics of neural networks. Neural networks are AI systems inspired by the human brain, made up of layers of interconnected neurons that learn by adjusting weights between them. They process data through input, hidden, and output layers to recognize patterns and make predictions. These networks are used in fields like computer vision, language processing, and autonomous systems. Their ability to model complex relationships makes them a core part of modern machine learning. Architecture of neural networks. The architecture of neural networks includes neurons, units that process data, layers, input, hidden, and output, and activation functions that help the network learn complex patterns by deciding whether a neuron should be activated. Let's delve deeper into the architecture and training of neural networks, and examine various deep learning models and their applications. Architecture of neural networks, neurons. Neurons are units in a neural network that take weighted inputs, apply a transformation with a bias, pass it through an activation function, and output the result to the next layer. 1. Input, neuron takes weighted inputs plus a bias. 2. Transformation, applies activation to the weighted sum. 3. Output, sends the activated value to the next layer. Architecture of neural networks, layers. Layers, neural networks are organized into layers, each consisting of multiple neurons. The primary types of layers are 1. Input layer. Receives raw data, each neuron represents a feature. 2. Hidden layers. Process and transform data to learn patterns. 3. Output layer. Produces the final prediction or classification. Architecture of neural networks, activation functions. Activation functions. Activation functions introduce nonlinearity into the network, allowing it to learn and model complex patterns. Common activation functions include 1. Sigmoid. Maps values between 0 and 1, good for binary classification. 2. ReLU. Outputs positive values or 0, commonly used in hidden layers. 3. TAN. Maps values between -1 and 1, centers data around 0. 4. Softmax. Converts outputs to probabilities for multi-class classification. Training neural networks, forward propagation, back propagation. Training a neural network involves adjusting its parameters, weights and biases, to minimize the error in its predictions. This process requires two key steps, forward propagation and back propagation. Let's delve deeper into them. Training neural networks, forward propagation. Forward propagation is the process of passing input data through the neural network to obtain predictions. It involves 1. Data input. Raw data enters the input layer. 2. Layer computations. Layers process data using weights and activation functions. 3. Output generation. The output layer produces the predictions. Training neural networks, backpropagation. Backpropagation is the algorithm used to train neural networks by adjusting the weights based on the error between the predicted and actual outputs. It involves Introduction to Deep Learning Models, CNNs, RNNs. Deep learning is a subset of machine learning that uses neural networks with many layers to model complex patterns in data. It powers advanced applications like image recognition and natural language processing. Common deep learning models include CNNs for images and RNNs for sequence data. Deep learning models like CNNs and RNNs are specialized neural networks designed for tasks like image processing, CNNs, and sequence data like text or time series, RNNs. Convolutional neural networks, CNNs. CNNs are specialized neural networks designed for processing grid-like data, such as images. They leverage convolutional layers to automatically extract features from the data. Key components include 1. Convolutional layers. 2. Pooling layers. 3. Fully connected layers. Let's explore each component. 1. Convolutional layers. Use filters to detect features like edges in the input data. 2. Pooling layers. Reduce feature map size to simplify computation and prevent overfitting. 3. Fully connected layers. Link all neurons to make final predictions or classifications. Recurrent neural networks, RNNs. RNNs are designed for sequential data, such as time series or natural language. They have the capability to maintain a memory of previous inputs through their internal state. Key components include 1. Recurrent layers. 2. Long short-term memory, LSTM. 3. Gated recurrent unit, GRU. Let's explore each component. 1. Recurrent layers keep a memory of past inputs to understand sequences, updates its memory and outputs based on current and previous inputs. 2. LSTM. An advanced RNN that handles long-term dependencies using gates. 3. GRU. A simpler, faster version of LSTM that still captures long-term patterns. Advantages of deep learning. 1. High accuracy. Deep learning models, particularly with large datasets and complex architectures, can achieve high levels of accuracy in tasks such as image and speech recognition. 2. Feature learning. Deep learning models automatically learn relevant features from raw data, reducing the need for manual feature engineering. This capability allows for more scalable and flexible solutions. 3. Handling large datasets. Deep learning models are well-suited for processing and learning from large volumes of data. They leverage powerful computational resources, such as GPUs, to handle massive datasets effectively. 4. Versatility. Deep learning techniques can be applied to a wide range of domains and tasks, including computer vision, natural language processing, and autonomous systems. Disadvantages of deep learning. 1. Data and computational requirements. Deep learning models require substantial amounts of labeled data and significant computational resources for training. 2. Interpretability issues. Deep learning models are often referred to as black boxes due to their complexity and lack of transparency in how they make decisions. 3. Overfitting risk. Deep learning models with many parameters are prone to overfitting, especially when trained on small datasets. 4. Training time. Training deep learning models can be time-consuming, requiring hours or even days to converge, depending on the complexity of the model and the size of the dataset. Applications. Image and speech recognition. 1. Image recognition. Deep learning, particularly with CNNs, has revolutionized image recognition by enabling computers to identify and classify objects within images. Applications include object detection. Finds and locates objects in images. Facial recognition. Identifies people using facial features. Medical imaging. Analyzes scans to detect and diagnose issues. 2. Speech recognition. Deep learning models, especially RNNs and their variants like LSTMs, have significantly advanced speech recognition capabilities. Applications include voice assistants, devices respond to spoken commands. Transcription services, convert speech to text. Speech-to-speech translation, translate spoken language in real time. Summary. This module covered the basics of neural networks and deep learning, including their architecture, training processes, and key models like CNNs and RNNs. It also discussed their strengths, limitations, and real-world applications. We highlighted the advantages and disadvantages of deep learning technologies. Congratulations on completing the module. You've gained a solid understanding of neural networks and deep learning, equipping you to design and implement powerful AI models for real-world applications. Keep up the great work.